Manufacturing a cell phone is a complex and multi-step process that involves several stages, from design to assembly. Here's a detailed breakdown. 1. Design and development. Concept and design. Engineers and designers create the initial concept and design of the phone, including its hardware and software specifications. Prototyping. A prototype is built to test the design and functionality. This stage involves multiple iterations to refine the product. 2. Component sourcing. Parts procurement. Components such as processors, memory chips, displays, cameras, and batteries are sourced from various suppliers. The cost of these parts can range from $30 to $300 depending on the quality and features. Quality control. Each component undergoes rigorous testing to ensure it meets quality standards. 3. Manufacturing and assembly. PCB manufacturing. The printed circuit board (PCB) is manufactured, which involves etching the circuit design onto the board and placing components like resistors, capacitors, and chips. Component assembly. Components are assembled onto the PCB using automated machines. This includes soldering and placing chips, connectors, and other parts. Screen assembly. The display is assembled, which may include touch sensors and protective glass. Final assembly. All parts, including the PCB, battery, camera, and casing, are assembled into the final product. This stage also includes software installation and initial testing. 4. Testing and quality assurance. Functional testing. Each phone undergoes functional testing to ensure all features work correctly. Stress testing. Phones are subjected to stress tests to check durability and performance under extreme conditions. Quality control. Final quality checks are performed to ensure the phone meets all specifications and standards. 5. Packaging and shipping. Packaging. Phones are packaged with accessories like chargers, earphones, and manuals. Shipping. Packaged phones are shipped to distribution centers and retailers. Cost breakdown. The total cost of manufacturing a smartphone can vary widely based on the type and quality of components used. Here's a general breakdown. Parts, $30 to $300. Labor, $10 to $50. The manufacturing of cell phones has several significant environmental impacts. Here are some key areas of concern. 1. Carbon emissions. Manufacturing process. The production of smartphones generates a substantial amount of carbon dioxide, CO2, emissions. In 2022, it was estimated that smartphones produced 146 million tons of CO2 emissions, with 95% of these emissions coming from manufacturing processes, including the extraction of raw materials and shipping. 2. Resource extraction. Raw materials. Smartphones require various rare earth elements like lithium, neodymium, and antimony. The extraction and refining of these materials can lead to significant environmental degradation, including habitat destruction and pollution. Mining impact. Mining for these materials often involves harmful practices that can lead to soil erosion, water contamination, and loss of biodiversity. 3. Energy consumption. Manufacturing facilities. The production of components, especially semiconductors, consumes a large amount of energy. Maintaining the necessary conditions in semiconductor fabrication plants, such as constant temperature and humidity, is energy-intensive. 4. E-waste. Disposal. The disposal of smartphones contributes to the growing problem of electronic waste, e-waste. By 2030, it is expected that 82 million tons of e-waste will be generated annually. Improper disposal can lead to the release of toxic substances into the environment. Recycling challenges. While recycling can mitigate some of these impacts, the process is often complex and not all materials can be efficiently recovered. 5. Water usage. Production processes. The manufacturing of smartphones, particularly the production of semiconductors, requires significant amounts of water. This can strain local water resources, especially in regions already facing water scarcity. 6. Social impacts. Labor conditions. The extraction of raw materials often occurs in regions with poor labor conditions, leading to social and ethical concerns. Workers may face hazardous conditions, low wages, and exploitation. Mitigation strategies. To reduce the environmental impact of smartphone manufacturing, several strategies can be employed. Extending product lifespan. Encouraging consumers to use their devices longer can reduce the demand for new phones and the associated environmental impact. Recycling and reuse. Improving recycling processes and increasing the use of recycled materials in manufacturing can help reduce the need for new raw materials. Sustainable practices. Manufacturers can adopt more sustainable practices, such as using renewable energy sources and improving energy efficiency in production. If you have any more questions,